So hi, we are Team Search 2.0, and Search 2.0 is a CLI tool for embedding and retrieving local PDFs and code files using natural language queries. For instance, users can search academic papers, presentations, slides, or government forms uh, in PDF format and retrieve specific pages of interest. And similarly, for large code bases, the tool can locate specific functions or section of code by simply prompting it with a query.
So now we'll go for the demo too. So initially, it is a CLI tool. So I'm running it from a CLI. So basically, we have two commands here. One is the PA, that is the PDF assistant. Another one is the CS, that is the code assistant. First, we'll look upon the PDF assistant tool.
So right now, what we are doing is to paste a command for retrieving the file based on a natural query.
So already a file with multi-head attention is embedded, and we found the relevant PDF file which has the content, specific content. Now we'll search all the files which have been embedded already. So these are the files which have been already embedded here. And now we'll newly embed an file with a local file path. So I'm running it on a Windows machine. So I'm giving an Windows file path here. So the file path is test here. The file is oh. So I'm doing a file path for embedding right now, a PDF file. It will take a little time to parse the PDF file and do the embeddings. So we are waiting for the file to be embedded here still. Okay. Now you can see the response here that the file is successfully embedded here. So this is about the PDF tool. Now I'll move on to the code search tool. The command is CS for that. And Initially, I will say find a Java file embedded. So I'm asking to find a Java file which is embedded. So initially there are no Java files which are embedded in the system. Now I'll give a path. Embed. I'll give a specific Java file here, person.java for the embedding. So the file has been successfully embedded with a success message here. Now I'll search on that embedding. So here we can see the specific explanation of the class which has been embedded. So it is basically the person Pojo class, and we get the attributes which are there in the Pojo. Now, where the first name first name attribute is used. So I'm trying to find a snippet where the first name attribute is used. So here we found a Java class with person which uses first name as an attribute with corresponding getter and setter methods. So in this manner, you can pass an specific code file, and you can find the snippets. So this is about the demo here. Now we will explain our tool in detail.
So we use our architecture is basically cloud native microservices based system built with Fast API on AWS Fargate for scalable ML model serving, and Fast API serves as an entry point interacting with services that encapsulate business logic and delegate database operations to repositories backed by AWS RDS. The CLI triggers these endpoints, enabling event-driven execution. And so this design pretty much follow the repository and service layer pattern, ensuring modularity, maintainability, and scalability. And both tools are used by one single agent, which is powered by Cloud 3.5 Sonnet. So we can move on to the next section. And this is the class diagram for PDFSearchTool. As you can see here, we have several services, especially search service uses embedding and uses indexing. So that's why we have dependency injection here. And we also have can you zoom in a little bit? We also have PDF conversion service, which has connection with benchmark service because in order to do benchmarking, we need to first of all convert the PDF to images. We and for right after PDF conversion, we also need to index the file. That's why we have connection between embedding and indexing. And could you go to next section? Given our service layer architecture, we also have repository in order to interact with database. and pretty much the services have only the services have the direct interaction with repositories for flattened embedding repository, index and strategy repository, query repository, uh, page repository, embedding repository, and in file repository. And all of them are children of repository, which is a base class. Since for our fast API, we have a lot of endpoints for including the default endpoint of getting all the files, post requests to do the search or benchmarking the rack system in order to know its recall precision, scores, etc. We also have embedding uh, endpoints specifically to embed one single file, multiple files, or to do benchmarking against the Vidora PDF datasets. And we can also get all the files based on the ID or a bunch of files based on multiple IDs, and as well as indexing based on different strategies accordingly.
So now coming to the code search tool. Uh, Code search tool allows an user to upload multiple code files and search the snippets based on that in a much easier way. So the architecture of code search tool is this one. So initially we have a services here. The services contains the file embedding processor, the query search processor, and the RAG processor. And we also have the repositories here, the file repository and the query repository. Basically, the repository helps us to store the file embeddings in the Postgres vector database. And finally, this is connected with the Claude, the LLM agent, which is the Claude 3.5 Sonnet. And we have this is a microservice architecture, and we have the endpoints with fast APIs. So this is the schema diagram where I have the code files data, metadata, and the vector embedding specifically. And I have a search table which catches the recently searched query. So coming to the API documentation, we have an post with a search and embeddings to upload a single file and upload multiple files. So coming to the test case for the PDF search tool.
For PDF search tools, we use PyTest and PyTest async seal in order to benchmark in order to test API endpoints. So we conducted unit tests, integration tests, and API endpoint tests in order to test interaction between services and repositories. That's for integration tests. And we also test all the endpoints in order to ensure the integrity of the integrity of all the endpoints, as well as the validity of schemas in database. So that's why we also have a database test in order to ensure the correctness of the SQL alchemy.
These are the test cases for the PDF search tool. And coming to the test case for the code search tool, we use the PyTest similar to the PDF search tool. And we do an integration testing where we embed the file specifically, and we do also an unit test to test the small parts of the code. So these are the tests which are there for the code search tool.
For the CI/CD, we have a pre-commit hooks as well as YAML file in order for GitHub action. So whenever we push a commit or we make a pull request, it's able to automatically check our code quality, ensure that the code base is clean, and also ensure that the quality is there. And we also use rough to format do the linking before the push.
So These are the examples of how we use the chat with Claude in our code specifically, and these are the sample input and output response. Can you explain the Scrum summary?
So for the last part about the Scrum, so we initially created all our user stories, and we picked our own individual tasks that we want to work on. For me, it was PDF search tool, and for my teammate, he was working on code search tool. Um, so pretty much we completed all the tasks, most of the tasks successfully. So it was pretty. I think it is pretty successful project overall.
I'll stop sharing my screen. I think